Hello everyone, welcome to my class. In today's class, I'm going to cover solving basic trigonometric equations. So let me start the class right away. First, definition of trigonometric equations. An equations involving trigonometric functions of an unknown angle is called a trigonometric equation. So the trig equations containing a single trig function is called a basic trig equations. For example, 2 sine x equals to radical 2. So here we have only one trigonometric function, sine x. Second, radical 3 tan x equals to negative 1. Similarly, 2 sine square x plus 7 sine x minus 4 equals to 0. So again, in these equations we have only one trigonometric function, which is a sine x. Quick note, the trig equations are conditional and their solutions are angles. The smallest solution angle satisfying the trig equation is called the principal root. The general solution is the complete set of values of the unknown angle satisfying the trig equations. Once the principal root is found, roots in the interval 0 to 2 pi or the general solutions can be found using reference angles and adding the integer multiples of the period of that trigonometric functions. Just a quick example. Example 1. Let me scroll down. That's better. Solve 2 sine x equals to radical 2. Let's begin the solutions. Divide both sides by 2. Then we have sine x equals to radical 2 over 2. Then ask questions to yourself, which angles have sine radical 2 over 2. So that means we have two choices. One choice is at 45 degree. Another choice is 135 degree. But the inverse sine function has range, lies between minus pi half to positive pi half. So we need to pick an angle in the first quadrant, not on the second quadrant. So our answer is pi fourth in first quadrant. That's the idea. So the next, let's apply both sides sine inverse. Then sine inverse sine x, that's my left hand side. On the right hand side we have sine inverse radical 2 over 2. This sine inverse and sine cancel, so only it gives us x. So x equals to sine inverse radical 2 over 2. And here we know on the first diagram here, radical 2 over 2 is 1 over radical 2. So that's the sine value. So the sine at pi fourth is 1 over radical 2. That means radical 2 over 2. So the inverse sine radical 2 over 2 is simply pi fourth. So we have x equals to pi fourth. Now this is a principal root which lies in first quadrant. Next, all solutions in the interval 0 to 2 pi are, one is x equals to pi fourth is here, and another one is its symmetric point here. The angle is 135 degree or 3 pi over 4. Similarly, then all possible real solutions are on this angle, just add 2 pi times integer k. Similarly, add 2 pi times integer k to this angle. So the general solutions are x equals to pi fourth plus 2 pi k, where k is an integer, and x equals to 3 pi over 4 plus 2 pi k, where k is an integer. So let me talk the visualization here. So here we are solving sine x equals to radical 2 over 2. By the way, radical 2 over 2 is 1 over radical 2. So now I do the graph of two functions. One is y equals to sine x. Let me show this one. So this is y equals to sine x. And another graph I drew here, y equals to 1 over radical 2. This is line. y equals to 1 over radical 2. These two graphs intersect at here and here. Here, that's the pi fourth we discussed earlier, and this one is a 3 pi over 4, 135 degree, and only after 2 pi, which is here. So in 0 to 2 pi intervals, we only care these two solutions. I hope this makes sense to you all here. One is pi fourth, one is 3 pi over 4. Great. But this general solutions contains all possible real solutions. So that means this graph, they intersects after 2 pi also, here, 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 here. Similarly, before pi fourth also. Maybe this sine curve goes up and again intersect here and goes down, intersect there, and again, because sine curve is just a wave graph, right? Awesome. So I hope this makes sense to you all. This example 1. Now let's move on. So the questions we ask to ourselves at this time, how to solve the trigonometric equations. So the idea, let me scroll this way, that's better. Basic solution method. Isolate the trigonometric term containing the variables and apply the appropriate trig inverse. One can also solve using factoring, ideas of unit circle, properties of right triangle, trigonometric graphs, and the basic trig identities. Quick remark, that's better. The inverse sine function returns an angle either in first quadrant or fourth quadrant, whereas inverse cosine returns angle in either first quadrant or second quadrant. When the inverse trigonometric functions are applied, the result is only the principal root, and the other solutions may exist depending on the interval under considerations. That part we talked in our earlier class. The range of inverse sine function is minus pi half to pi half, minus pi half to positive pi half, whereas the range of inverse cosine function is 0 to pi. That means first quadrant and second quadrant. Now let's do other example. Example 2, that's better. Find the principal root of trigonometric equations given in part A and part B. First part A, let's solve negative 4 times cosine x equals to 2 times radical 3. Begin the solutions. First we want to isolate the trig term. So here I want to isolate the cosine x, so let's divide both sides by negative 4. So we have here cosine x equals to 2 times radical 3 over negative 4. So 2 cancel 4 2 times. So we have cosine x equals to minus radical 3 over 2. I hope this all makes sense to you all. Then apply the cosine inverse both sides. Then we have cosine inverse cosine x equals to cosine inverse of minus radical 3 over 2. So the left side is simply the x, and then the right side. So now let's ask questions to ourselves. What angles cosine gives us negative 3 over 2? So that means cosine is negative in the second quadrant and third quadrant. But the range of cosine inverse is 0 to pi. That means it's not in third quadrant. So I have to pick an angle in second quadrant. So then let's pick an angle in second quadrant. Note, the range of the inverse cosine is 0 pi, so the principal root lies there. Since the values of cosine x is negative, and hence we need to choose an angle in second quadrant, hence x equals to pi over 6 or 150 degree. Let me visualize. So that's better. So now here's I graphed. This is the cosine functions graph. And also I graph y equals to negative radical 3 over 2. This is this line. This is this line. And then they intersect here. This lies in the second quadrant. I hope this makes sense to you all. So this is the solution we found here, 5 pi over 6. Great. Now let's move on. Let's do part B, and that's better. Solve negative 5/3 sine x equals to 5/6. Begin the solutions. Isolate the trigonometric term. So let's multiply both sides by 3/5. So 3/5. So the left side 3/5 cancel out. Also there is a minus. So this minus goes to this side. Then we are multiplying by 3/5. So 5 cancel. 3 cancel 6 2 times. So we have sine x equals to -1/2. Then take inverse both sides. Then we have sine inverse sine x equals to sine inverse -1/2. So then here, so here we are solving sine x equals to -1/2. So the sine function is negative on either third quadrant or fourth quadrant, but the inverse sine function's range lies in fourth quadrant, so I need to pick an angle in fourth quadrant. Hence x equals to -pi/6. Since we know sine pi/6 is 1/2, then I have a minus sign. That's why I need to put the minus there. That means I'm picking x equals to -pi/6. That's a negative 30 degree. I hope this makes sense to you all. So now let me visualize here. So here's I graphed y equals to sine functions. Maybe that's better. And y equals to -1/2. This is the -1/2 line. And we are talking this intersecting point, which is -pi/6, or that's the 2 pi minus pi/6. 6 times 2, 12, 12 minus pi, 11 pi/6. Awesome. Now let's move on. Example 3. Find all solutions in the interval 0 to 2 pi of trigonometric equations given in part A and B. Part A, solve 3 secant x equals to -6. Begin the solutions. Divide both sides by 3. We have secant x equals to -2. Since secant x is the reciprocal of cosine x, so just flip it for cosine x. So cosine x equals to -1/2. The cosine x is negative in the second quadrant and third quadrant. So to solve this equation, multiply both sides by cosine inverse x. So we have here cosine inverse cosine x equals to cosine inverse -1/2. But cosine inverse range is 0 to pi, so I need to pick an angle in second quadrant. So hence x equals to pi minus pi/3. Since cosine pi/3 is 1/2, so the angle is 2 pi/3. And the angle in third quadrant is x equals to pi plus pi/3, which is 4 pi/3. I hope this idea makes sense to you. Now let me visualize. So now here's I'm graphing y equals to cosine x and y equals to -1/2, and I'm looking for intersecting point. So here, this is y equals to cosine x graph, and this is y equals to -1/2 line. Here we are looking for these two intersections in the interval 0 to 2 pi. So here's one, which is in here, so that's in the second quadrant, and this one is in the third quadrant. That's we found in 2 pi/3 and 4 pi/3. I hope this makes sense to you all. Now let's move on. Awesome. Now let's move on. Let's do part B. Solve 4 times sine square x equals to 2. Begin the solution. Divide both sides by 4. We have sine square x equals to 1/2. Take the square root both sides. Sine x equals to plus minus 1/2. So that means we have sine x equals to plus 1/2 and sine x equals to minus 1/2. First, sine x equals to plus 1/2. So we found the angle in first quadrant on the second quadrant. Similarly, for sine x equals to minus 1/2, we found the angle in third quadrant and in the fourth quadrant. So we have total 4 answers here. So in the next step, multiply by sine inverse. We have sine inverse of sine x equals to sine inverse of plus minus 1 over radical 2. So hence, the required solutions are in first quadrant x equals to pi fourth, and in the second quadrant 3 pi over 4, and in the third quadrant 5 pi over 4, that means pi plus pi fourth, and in the fourth quadrant it's a 2 pi minus pi fourth, that's a 7 pi over 4. So let me visualize these solutions here, so that's better. So this is the sine graph, and this is y equals to 1 over radical 2, and this line is y equals to minus 1 over radical 2. So then this graph intersects here, that's in the first quadrant, this is the second quadrant, and here this is the third quadrant, and here this is the fourth quadrant. So we have total 4 solutions here. So this corresponds to pi fourth, this corresponds to 3 pi over 4, this corresponds to 5 pi over 4, and this corresponds to here 7 pi over 4. I hope this makes sense to you all. Now let's move on. Example 4. Now this time let's find all real solutions of trig equations. Part A, example 4. Solve 2 sine square x plus 7 sine x minus 4 equals to 0. So this equation is in quadratic in sine function. So let's factorize. So in the solutions, factorize is we have 2 factors, 2 sine x minus 1 and sine x plus 4 equals to 0. You can verify easily. Multiply, you FOIL it, it gives you this back. So 2 sine x times sine x to sine square x, 2 sine x plus 2 sine x times 4, 8 sine x minus 1 times sine x minus sine x. So 8 sine x minus sine x is 7 sine x, and the last is minus 1 times 4 is minus 4. Great. So next, now here we have the product of 2 numbers equals to 0 implies either one should be 0. So either the first factor equals to 0, so 2 sine x minus 1 equals to 0. Take 1 to the right side and divide by 2. This implies sine x equals to 1/2. Multiply both sides by sine inverse. We have sine inverse sine x equals to sine inverse 1/2. So the sine x is 1/2. This is either in first quadrant or the second quadrant where sine is positive. So in first quadrant the angle is 30 degree, and in the second quadrant the angle is 150 degree. Or now from the second part, from this second factor, sine x plus 4 equals to 0. This implies sine x equals to minus 4, but we know sine x has maximum plus 1 and minimum minus 1, so this value is not possible, so we disregard these solutions. So now we have only these 2 solutions. One is pi over 6, 30 degree, another one is 5 pi over 6, 150 degree. So let me find all possible real solutions. So that means I need to add 2 pi times the integer k to this angle, similarly to this angle, because 2 pi is the period of sine functions. So our general solution is then x equals to pi over 6 plus 2 pi k, and x equals to 5 pi over 6 plus 2 pi k. Great. So here I'm only visualizing the solution in the interval 0 to 2 pi. So that means here this is the sine curve, and the line y equals to 1/2. Y equals to 1/2 goes from here, and they intersect here and here before 2 pi. After 2 pi they intersect here, but I'm only visualizing this 2 for this part here. One is 30 degree here and one is 150 degree here. I hope this makes sense to you all. But this answer gives me all possible solutions. That means this sine curve goes like this, similar to this side, and this straight line at y equals to 1/2 intersect many points. These are given by this, depends on this k here. I hope this makes sense to you all. Now let's move on. Part B, solve -8 times sine x over 2 equals to -4 times radical 3. So now we have the half angle here. So let's begin the solutions. Divide both sides by -8. So then negative cancels. 8 divides 2 times. So we have sine x over 2 equals to radical 3 over 2. Take sine inverse both sides. So we have sine inverse sine x over 2 equals to sine inverse radical 3 over 2. Then sine inverse sine cancels. It gives you only x over 2. And we know this sine inverse radical 3 over 2 is pi over 3 and 2 pi over 3. You know, sine 60 degrees radical 3 over 2 and sine 120 degrees radical 3 over 2. So we have two solutions. Hence, all real solutions are pi over 3 plus 2 pi k. So here, let's solve this here. So let's multiply both sides by 2. Then left side is simply x. Then on the right side, 2 pi over 3 plus 4 pi k, which is here. Great. Similarly, on this angle, so x over 2 equals 2 pi over 3 plus 2 pi k. Multiply both sides by 2. Then it turns out that x equals to 4 pi over 3 plus 4 pi k. Awesome. Next, let me visualize the solutions. So here, this is y equals to sine x over 2 graph. And this is the line y equals to radical 3 over 2. And the intersecting point is here and here between 0 to 2 pi. So one is 2 pi over 3. So this is 2 pi over 3. And this is 4 pi over 3. This is 4 pi over 3. Great. I hope it makes sense to you all. Now let's move on. Example 5. In example 5, let's find principal root, root in interval 0 to pi, and all real solutions of these trigonometric equations. The trigonometric equation given to us is 8 tan x plus 7 times radical 3 equals to minus radical 3. Let's begin the solutions. So first, write down these trigonometric equations. Then next, subtract 7 radical 3 both sides. So we have 8 tan x equals to, this goes to this side, becomes minus. So we have minus 7 radical 3 minus radical 3 is minus 8 radical 3. Divide both sides by 8. We have tan x equals to minus radical 3. Multiply by tan inverse both sides. We have tan inverse tan x equals to tan inverse of negative radical 3. So we are looking angle in second quadrant and fourth quadrant where tangent is negative. Then left side is x equals to, one is 2 pi over 3 in second quadrant and one is 5 pi over 3 in fourth quadrant. Keep in mind that pi is the period of tangent functions. So here we found x equals to 120 degree and 300 degree. But for the principal root, I need to look for the smaller angle. So the reference angle, so that means for 2 pi over 3, I need to subtract the pi. So for the principal root, x equals to 2 pi over 3 minus pi. Solve these two fractions. So here 2 pi by 3 minus pi over 1. LCD is 3. Then multiply this pi by 3 and divide by 3. Then 2 pi minus 3 pi over 3. That means minus pi over 3. So minus pi over 3 is the principal root. Next, let's find all solutions in the interval 0 to 2 pi. That's we already found here. One is 2 pi over 3 in the second quadrant and one in third quadrant, which is 5 pi over 3. I hope it makes sense to you all. Third, Now let's find, maybe that's better, find all real solutions, general solutions. Then we have this root here. We simply add period times the integer. Period of tangent function is pi. So all real solutions are x equals to 2 pi over 3 plus k times pi, and x equals to 5 pi over 3 plus k times pi. Awesome. I hope it makes sense to you all. By the way, we can merge these two solutions into one, which is x equals to 2 pi over 3 plus k pi. Let me check quickly here. If you put k equals to 1, then 2 pi over 3 plus pi, then solve these two fractions here. So multiply this pi and divide by pi by 3. So we have LCD is 3, then 2 pi plus 3 pi over 3, 5 pi over 3, which is here. Great, so we can combine these two into one. Now let me visualize our solutions here. So what am I graphing here? I'm graphing, one is y equals to tan x and another is y equals to minus radical 3. So here, this is the tangent functions graph. We are familiar. We have a vertical asymptote by half, vertical asymptote is 3 pi over 2. I'm only picking the interval 0 to 2 pi here. And another one is y equals to minus radical 3. So this is y equals to minus radical 3. And we are talking about this intersection here, this one and this one. So this one is 2 pi over 3 and this one is 5 pi over 3. I hope it makes sense to you all. Let's move on. Let's do example 6. Solve the trig equations using Trig-Identity. The given trig equation is 4 times sine square x minus 4 times cosine square x equals to 2 times radical 3. Begin the solutions. I copied the equation as it is. Then here I factor negative 4 out, and remaining terms here, cosine square x minus sine square x, because I pulled minus out, so this term's first and this term's second here, equals to right hand side as it is. Next, we know cosine 2x equals to cosine square x minus sine square x. So I use the Trig-Identity here, and right hand side I copied as it is, and I divide, next step, I divide both sides by negative 4. Then we have cosine 2x left hand side equals to 2 times radical 3 divided by negative 4. So just cancel the 2 and negative 4. So this gives me 1 over negative 2, radical 3 as it is. So we have cosine 2x equals to minus radical 3 over 2. I hope this calculation makes sense to you all. Now let's move on. It says refer question number 2a. So let me show you what's in the 2a. We are here. Oh, 2a here. We are solving here cosine x equals to minus radical 3 over 2. But in our example 6, we have cosine of 2x here. Okay. So let me scroll down again. Yep. So we have angle is 2x here. So then cosine x is negative in second quadrant and in third quadrant. So I need to pick angle in second and third quadrant. So here, multiply both sides by inverse cosine. Then we have left side is 2x, right side is cosine inverse radical 3 over 2. Oh, minus. It's a typo between the minus here. So that means 2x equals to, one angle is 150 degree in second quadrant and another one is 7 pi over 6 or 210 degree in third quadrant. Hence the general solution is 2x equals to 5 pi over 6 plus 2 pi k. Simplify. This gives you x equals to 5 pi over 12 plus pi k. And in second, 2x equals to 7 pi over 6 plus 2 pi k. That's better. Simplify, it gives you x equals to 7 pi over 12 plus pi k. This pi is a period for this double angle. I hope this makes sense to you all. Now let me visualize here. So here, this is the cosine graph, the regular cosine graph, but our angle is 2 times x, so that means we are shrinking the cosine graph. Maybe that's better. Yeah. Then this is the cosine 2x graph, and we found the angle here and here. This is the in second quadrant, and this is in the third quadrant, and this is the line y equals to minus radical 3 over 2. So I hope this makes sense to you all. Now we finish solving basic trigonometric equations, and in next class we will cover solving general trigonometric equations. Thank you.